Alright, so we're going to finish with this last part. So, graph the function, state the domain and range. So, I'm going to first, this is a square root function, just so you know, and I'm going to remind you how to graph the parent function of the square root function because it's helpful. So, y equals the square root of x. So, it's going to start here at 0, 0, okay, and, well, let's just say we plug in 1. So square root of 1 is going to be 1. So if I plug in 1, I get 1 out of it. Okay. And then, well, the next number I want to plug into a square root is 4 because I can't take the square root of 2 or 3 without getting decimals, right? So if I plug in 4, the square root of 4 is going to be equal to 2. And then the next one would be 9. The square root of 9 would be equal to 3. Another way, if you want to remember, is that this is a sideways parabola, so you can use the 1, 3, 5 rule if you want to do that too. But in any case, we have here our square root parent function. And then what I'm going to do to graph this function here is just apply the transformations. So we have up 5 and a stretch of 2. So let's do the stretch of 2 first in this case right here. I don't think it really should matter. But so the stretch of 2 just means that the vertical distance that each point from the x-axis, so in this case the vertical distance is 1, 2, the vertical distance here is 3, all of these are going to be stretched by 2. So now this distance right here would be at 2, this distance right here would be at 4, and the distance here would now be at 6. Oops, 6. Okay. So there's the stretch by 2, and then we're going to move it up 5. So all of these points right here, including this origin point, is all going to be moved up 5, so on and so forth. So 1, 2, 3, 4, 5. I'm going to take this point right here, move it up 1, 2, 3, 4, 5. Move this point right here, 1, 2, 3, 4, 5. This one's going to be too far up. I'm honestly just going to erase that. Okay, so then you have your new function right there. Just be familiar with all the transformation rules. So if you had a negative square root of x, this would be a reflection over the x-axis. That would mean that it would go this way instead of upwards. So there's that. If you had square root of negative x, this would be a reflection of the y-axis, meaning that my function would be going to the left instead of to the right. Excuse me. If I have square root of x minus 2, this would be a shift to the right 2. If it was plus 2, it'd be left 2, so on and so forth. So just be familiar with all transformation rules. Okay, finally for the domain and range on these problems right here, it helps if you can identify this first point. In this case, it's 0, 5. Remember that this coordinate point is x and y. So domain is always recorded with x, range always recorded with y. So let's think x, which is left and right. So the value here is 0. Does the function go to the right, which would mean that it would be greater than, or would it go to the left, which would be less than? In this case, the function goes right, so x would be greater than or equal to 0. For the y value, well, range is always up or down. So that's why we use the y. We start with 5. Now it's just a matter if it's going to be greater than or less than. So if we move up, that's greater than or equal to. If the function's going to go down from that point, it's going to be less than or equal to. Since the function's moving up, that's greater than or equal to 5. There you go. Okay, identify all transformations. So I can spot 3. 1, 2, and 3. So here, reflection in the x-axis would be first one. So reflection in the x-axis. The 1/4 would be a shrink, vertical shrink. By 1/4. And this plus 1 would be shift up 1. Okay. This one I also see 3. I see 1, 2, 3. First one would be a vertical stretch by 5. Inside here, that would be a horizontal shift, right 6. And then it would be down 2, vertical shift down 2. Okay, and that'd be it for those. Okay, on this last page right here, got 3 more problems. Determine whether the functions are inverses. So this has to be done by composition, these 2 problems. So by composition, I mean you have to show that f of g of x is equal to x and show that g of f of x is equal to x, or you have to show that they are not. So let's do that here. Let's start by f of g of x, which means I'm going to take g of x, and g of x is inside of f, so this has to be plugged into that spot right there. So it's going to be equal to the cube root of 8x cubed plus 6 minus 6 divided by 8. Okay, so see again, this is g of x function. It's been plugged into f of x. And then we'll see if we can simplify. Excuse me. Okay, so what I notice here, the 8s cannot simplify first. The 6s have to simplify first. So those would cancel. So this will be equal to the cube root of 8x cubed divided by 8 now. Now the 8s can cancel. So I get the cube root of x cubed, and now the cube root and the exponent will cancel, leaving me with just x. And there you go, we have our first part done, but we also have to show g of f of x is also x. So we'll do g of f of x. So that means this part right here is going to go right here. So I'm going to have 8 parentheses cube root of x minus 6 over 8. All that cubed plus 6. So again, you still have the cubed right here, the 8 right here, the plus 6 outside. X has now been changed to be f of x. Okay, and then you're going to see if it can simplify. I can't simplify these first. The first thing that's going to have to go is the cube roots. That's the thing, because 8 can't cancel with that yet either. Yeah, so those are going to have to go first. So then I'm going to have 8 times by x minus 6 over 8. There's no more cube root plus 6. I can't cancel these out first. That's going to have to come first, division multiplication. So those are going to cancel. So I'm going to get x minus 6 plus 6, and then those would cancel, and I'd get x. So therefore, f and g are functions, are inverses, sorry. Okay, let's see if we can do the same thing here. Let's start by f of g of x. So that would mean that g is on the inside, so this has to be plugged in right there. So we still have the 4. I'm going to use parentheses, negative x minus 3 divided by 4 squared plus 3. So you still see that I still have the 3 still being squared, still have the 4, just wherever the x is, that's being replaced with all of g. Now, we really don't have to go far here. The 4s can't cancel, the 3s can't cancel, but it doesn't matter anyways, because this squared will not cancel with anything inside here. So if it doesn't, kind of like over here where it did here, where the cubed and the cube root would cancel, we don't have that here, which basically just means that this will not equal x. It can't cancel, it can't undo, all the operations have to be able to undo themselves in the right order. Since there is no square root, which would be the inverse operation of something being squared, it's not possible. So therefore, f and g in this case are not So f and g are not inverses. They will not, we can't show it by composition. Can't show it at all. So f and g are not inverses. Okay. All right, for the final question of this review, find the inverse of each function, then graph below. So I'm going to first by graphing this function right here. This is a cube root function, so let me remind you how to graph a cube root function. You have a point here. If you had y equals the cube, if you have y equals the cube root of x, if you plugged in 1, you'd get 1. If you plugged in -1, you get -1. Now the next cube root you can take is 8. The cube root of 8 is 2. The cube root of -8 would be -2. So this right here would be the parent function of the cube root of x. Okay, so let's go ahead and apply the transformations. It says that this is going to be moved to the right 3. So that means everything has to be moved to the right 3. So I'll put a point here. 1, 2, 3. Don't really have to worry about that point. 1, 2, 3. 1, 2, 3. So gonna get rid of that right there. There we go. Okay, and then now that I've graphed that, we want to find the inverse. We want to find the inverse of this function. Remember, to find inverse, you switch x and y spots. So say x is equal to the cube root of y minus 3. Then we have to solve for y. So let's get rid of the cube root by cubing both sides. Okay, so we'll have x cubed is equal to y minus 3. We'll add 3 to the other side. So final answer would be y equals x cubed plus 3. Okay, and then we'll graph this function as well because we're supposed to graph both. So this is a cube root function, or sorry, not a cube root, it's a cubed function, which means it has a point at the origin, and then it follows the same pattern as this function here, but just right side up, just flipped, rotated. So in this case right here, we're also moving up 3. So we would have points here, 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 and here, but all these points are going to be moved up 3. Okay, so that would be here, here, and here. And there. So it would go down like this, up like that. Another way you could do this is, remember that inverse functions have coordinate points flipped. So this point right here, which is at -5, -2, if you flip those to be -2, -5, it will also have a point, as you can see here. Here's this point. This is at the point 3, 0, 0, 3 would be right here. So you see how each point is flipped. So if you need help that way, you can also do that. Okay, and that wraps up everything for this review.